Good afternoon, everyone. Myself Sayyid Jamal Ahmed, and I am from Bihar. I am currently studying in second year in civil engineering. Today's presentation is on my bricks topics. Bricks. A small rectangular block typically made of fired or sun-dried clay used in construction. Structure face, the side face of brick. Header face, the end surface of the brick. Brick. A brick is a rectangular in shape and of size that can be conveniently handled with one hand. Brick may be made of burnt clay or mixture of sand and lime or of Portland cement concentrate. Clay bricks are commonly used since they are economical and easily available. Size of brick. Standard size. Standard size is 19 centimeter into 9 centimeter into 9 centimeter. Nominal size or size of brick along with mortar. Length of brick. Nominal size of brick is 20 centimeter into 10 centimeter into 10 centimeter. Length of brick 2 into width of brick plus thickness of mortar. Height of brick, width of brick. Conventional size of brick. Conventional size of brick is 22.4 centimeter into 11.4 centimeter into 7.6 centimeter. Country bricks or filled bricks 9 into 4.5 into 3. Classification of bricks. Classification of bricks is four types. First, on field practice. Second, on the basis of strength. Third, on the basis of use. And fourth, on the basis of type. First, on the field practice, first class brick, second class bricks, third class brick, and fourth class bricks. And third types on the basis of strength is class 3.5 to 35 mpm, and third class brick on the basis of use, first common brick, second basic brick, and third engineering bricks, and fourth on the basis of types, first solid, second perforated, third hollow, fourth cellular. Composition of brick. Silica, alumina, lime, oxide of iron, magnesia. Silica in present 50 to 60%, alumina 20 to 30%, lime 4 to 5%, oxide of iron 5 to 6%, and magnesia 1%. Oxide of iron 5 to 6%. Composition of brick. Silica 50 to 60%. Silica prevents the cracking, shrinkage, and warping of the brick, thereby impart uniform shape to it. It decreases shrinkage in burning and increases refractoriness. Third, if it is in excess, it destroys the cohesion between the particles, hence brick become too brittle. Second, alumina 20 to 30%. In first, alumina impact plasticity to the brick earth so that it can be easily molded in any design shape. Second, if it is in excess, it causes shrinkage and warping during the drying of the brick and makes the bricks too hard during the working process. Third, lime 4 to 5%. Lime also prevents the shrinkage of the bricks. It helps silica in clay to melt and help in binding, but if it is in excess, it causes the brick to melt during the burning. Thereby, it results in loss of the shape of brick. Some noted in down here. Composition, for oxide of iron 5 to 6%. Oxide of iron is ferrous, helps silica and lime to fuse with each other, hence leads to the development of strength in the bricks. Excess of iron makes brick dark blue. It also imparts reddish brown color in bricks, and last, improves impermeability. Fifth, magnesia 1%. Magnesia also prevents the shrinkage in bricks and imparts yellowish tint in bricks. Handful in ingredients in brick. First, lamp slaking. Slaking Selecting to volume increase, cracking and disintegration. Change the color of brick from red to yellow. Iron pyrites. Presence of the iron pyrites leads to crystallization and disintegration of brick during burning due to oxidation of these pyrites during burning process. The brick may split into pieces. Alkalis act as a flux during the burning of bricks, but if it is in excess, it causes the brick to fuse with each other, thereby resulting in its twisting and warping. Presence of alkalis also leads to efflorescence and staining in bricks. Pebbles or stones. Presence of stones and pebbles brick earth leads to the forming of weak and porous brick, load carrying capacity of which is comparatively reduced. The fifth, organic and vegetative matter. Presence of organic and vegetative matter helps in the burning of bricks, but if they are left unburnt, it results in the formation of gases during the decomposition, with which when escapes through the body of the bricks leads to the development of numerous voids, which results in a decreasing of load carrying capacity of bricks. Manufacturing of bricks. First, preparation of clay. Third, for second, molding. Third, drying. Fourth, burning. First, preparation of preparation of clay. Mm, and soiling. Top 200 mm of soil is thrown, and is not, as it consists of majority of impurities in it. Digging. Soil is dug out and spread over the level field to prepare it for next operation of cleaning. Impurities like stone, pebbles, organic matter, vegetation matter is removed from the brick earth. Weathering. After clearing the clay, it is imposed to the atmosphere for few weeks to few months for its softening, wrapping, and weathering. Um, uh, Blending. It is process in which different ingredients of brick earth is spread over the weathered clay in definite proportion and mixed. Tempering. Tempering is the process in which requested degree of hardness is induced in the brick earth to make it suitable for the next operation of molding. Tempering of the brick is done in pug mill. Molding of clay. The process of giving desired shape and size to the brick is termed as molding. Steel or wood molds are used, the size of which is approximately kept to be 8 to 12% greater than the size of the bricks in order to account for its shrinkage. Sorry. During molding, a mark of depth 10 to 20 mm is placed over the surface of the brick that is termed as frog mark, which serves the following two purpose. First, trade name of the manufacturer. Second, if act a key for mortar when the layer of brick is placed over it. Manufacturing of bricks. Second, molding of clay. Molding of the bricks can be done with the help of hand or with the help of machine. First, hand molded bricks are further of two types: ground molded bricks, table molded bricks. Qualities of table molded bricks in comparatively better than the quality of ground molded bricks, and its rate of molding is also comparatively better than ground molded bricks. Machine molded bricks are also of two types: plastic clay molded bricks, dry clay molded bricks. Quality of dry clay molded bricks is also comparatively better than plastic clay molded bricks. Drying. Molded bricks, if are directly burnt without drying, are too liable to get cracked due to excessive shrinkage. Hence, its drying is carried out before the burning of pressure, in which moisture content of the brick is reduced up to 2%. Drying of the bricks is carried out either naturally or artificially. During drying, bricks are also placed along their edge and never placed along their face in order to speed up the process of drying. Burning of bricks. Fourth, burning impact strength and hardness to the brick. It makes them dense and durable. Burning should be done properly. Done properly. Overburnt, brittle, easily broken. Underburnt, soft and unable to carry a designed load. Burning of the bricks is carried out at 1100 Celsius, at which silica and lime fuse with each other, thereby imparting strength of the brick. Burning clamps kills. Burning of bricks. Burning occurs in three states: dehydration, water smoking state 400 to 650 Celsius. Water from pores is driven off. Some of carbonaceous matter is burned. Oxidation period 650 to 900 Celsius. Remaining carbon is burnt. Ferrous iron is converted into ferric iron. Sand is added to alloy escaping of gases. Mm, uh, Vitrification 900 to 1100 Celsius to convert the mass into glass-like substance. Burning of bricks. A. Burning of bricks in clamps. Trapezoidal section of ground is taken and longer side is raised with a 50 degree. A brick wall in mud is constructed along the shorter side, and the fuel layer having thickness of 700 to 800 mm spread over the level ground. Fuel used for burning of the bricks in clams constitutes grass, husk, ash, wood, cow, dung, coal, dust, etc. Burning of bricks in clams. Burning of the brick in clam is carried out for 2 to 3 months. That is further following by its cooling for same duration. No supervision is required in clams. Moreover, since locally available fuel is used, the entire process is comparatively economical. There is no control over the fire in clams. Hence, the brick obtained are not of uniform quality. Sorry. Burning of burning of bricks in kilns. Kilns are large sized ovens that are used for the burning of bricks. Supply of the bricks from these kilns may either be continuously or intermittent. Accordingly, they are classified. Intermediate kilns is two types. First, updraft kiln, second, downdraft kiln, and continuous kilns is three types. First, bull trench kilns, second, Hoffman kiln, third, tunnel kiln. First, intermittent kiln. All the operation of loading, burning, cooling, and unloading is done sequentially, and hence the supply of the brick is not continuous from this kiln. Consists of two sets of main doors that are used for loading and unloading the brick. Bricks are placed in this kiln in the rows of approximately 4 to 5 brick thick and a head of approximately 6 to 8 brick thick. An open space between the two row of approx 2 to 3 bricks. This is left, which is used for placing the fuel. Intermediate kiln. Updraft kiln. If the movement of the gases is allowed to take place in vertically upward direction, it is termed as updraft kiln. Downdraft kiln. If the movement of gases is allowed to take place in vertically downward direction, it is termed as downdraft kiln. In downdraft kiln, permanent roof is provided along with the central chimney that permits the movement of the gases in downward direction. Qualities of the brick obtained from downdraft kilns is comparatively better than that of bricks obtained from updraft kilns. Second, continuous kiln. In continuous kiln, the supply of the brick is maintained to be continuous, as all the operation of loading, burning, cooling, and unloading is done simultaneously. A bull trench kiln. It includes two sets of movable chimneys that are always placed ahead of the section in which burning is to be carried out. Such an arrangement allows the preheating of the bricks in the chamber over which chimney is placed. Second, this kiln consists of number of sections in which all the operation of loading, burning, cooling, and unloading is done simultaneously. These kilns are generally oval, circular, and rectangular in plane. Hoffman kiln. This kiln is circular in plan and consists of fixed central chimney, and likely bull range kiln that consists of movable chimneys. This kiln consists of number of sections in which all the operation of loading, burning, cooling, and unloading is done. Tunnel kiln. This kiln is in the form of tunnel, which may either be rectangular, circular, or oval in plan. It consists of different stationary zones in which all the process of loading, burning, cooling, and unloading is done simultaneously. Bricks are placed either on a trolley or on conveyor belts, and is passed through different stationary zones in the tunnel. Quality testing of brick. For testing of brick, 50 bricks are taken at random for a lot, a maximum 50,000 bricks. The bricks should be at least stable, molded, well burned, and free from cracks. Dimension test. Where 20 pieces out of the selected pieces are taken and laid flat and checked for tolerance limit. The bricks should be of uniform shape and size. Conventional size of brick 22.4 centimeter, 11.4 into 6.7 6.7 centimeter. Weight of 1 meter cube bricks 1800 kg. Weight of one brick 3 to 5 3 to 6 kg. Next. Sound test. The brick should produce a clear metallic ringing sound when stuck with each other. Structure test. The brick should have uniform homogeneous structure across all the section. It should be free from any voids. Absorb test. Absorption test. The brick, when immersed in water from 24 hours, should not absorb water by more than 20% in case of first class brick, 22% in case of second class brick, 25% in case of third class bricks. Compressive strength test. The bricks should process minimum compressive strength of first class 10 Newton प्रति mm square per mm square, second class 7.5 N per mm square, third class 3.5 N per mm square. Toughness test. The brick should not break into pieces when dropped on level ground from the height of 1 meter. Hardness and abrasion test. The brick should possess sufficient hardness and does not show any sign of impression when scratched with fingernails. Alkali test. The brick, when immersed in water for 24 hours, should not show any sign of efflorescence and staining. Defect of brick. Overburning of bricks. If overburned, a soft molten mass is produced and the bricks lose their shape, not suitable for construction purpose. Underburned bricks. It causes a higher degree of water absorption and less compressive strength. The black core. When brick clay contains bituminous matter or carbon, and if it is underburned, it causes black core. Chafs. The deformation of the shape of bricks caused by the rainwater falling on hot bricks is known as chafs, checks, or cracks. This defect may be because of lumps of lime or excess of water. In case of the former, when bricks come in contact with water, the absorbed water reacts with lime nodules, causing expansion and a consequent disintegration of bricks. Varies shrinkage and burning cracks result when excess of water is added during brick manufacturing. Sports. Iron sulfide, if present in the brick, they result in dark surface spots on the brick surface. Such bricks, though not harmful, are unsuitable for exposed masonry works. Blisters. Broken blisters are generally caused on the surface of shower pipes and drain titles due to air impression during their molding. Lamination. They are caused by the trapped air in voids of clay. Lamination produced in lamina on the bricks faces which weather out on exposure. Such bricks are weak in structure. Brick masonry structure. Longer side face of the brick. Second header. The shorter side face of the brick used for a heating of walls. Different forms of brick: rounded ended bricks, canned bricks, double canned bricks, cornice brick, perforated bricks, bullnose bricks. Different from bricks, hollow bricks, and second coping bricks. Excuse me. Perforated bricks. Small holes may exceed 25% of the total volume of the brick. Hollow bricks. The total of holes which need not be small may exceed 25% of the volume of the brick. Closures. The portion of brick cut along its length. Uh, First half queen closer and quarter queen closer two half, and king closer one length and one with same cut, and fourth beveled closer one length and one with same cut, and width is halved. Okay, and fifth meted closer one length is halved and one width is halved full. Fourth bats. The portion of brick cut along its width. Half bat, three-quarter bat, beveled bat. Coin. It is the exterior angle at the face of the wall that is greater than equal to 90 degree. Bonding in bricks masonry. English bond. Alternate layer of the header and stretcher placed over each other to break the alignment of vertical joints to be in straight line. Queen closer in place next to queen header. Queen closer is never placed either at the starting or at the end of the course, as it is liable to get displaced. For the walls having thickness is odd, multiples of a half brick thick. Each course shows header on one face and stretcher on other face. Minimum lap available for stretcher in each course is 1 by 4 the length of brick. Elevation. English bond first brick wall, English bond first half brick walls. You can see. Second Flemish bond. It is the arrangement of bonding in which each course consists of alternate header and stretcher placed next to each other. In order to break the alignment of vertical joints to be in straight line, a queen closer is placed next to queen header in each alternate course. And third, four walls having thickness is in odd multiples of half brick thick. English bond is found to have higher strength than Flemish bond. Flemish bond is aesthetically more pleasing than English bond, but it requires skilled masonry works. English bond has more strength than Flemish bond. Important topic. A Flemish bond is found to be more economical than English bond, as number of half beds is used in this case, due to which wastage of brick is comparatively less. You can see a stretcher bond. To break alignment in a stretcher bond, half beds are used. It is arrangement of bonding in which all the bricks are laid along the stretcher. In order to the alignment of vertical joints to be in straight line, half beds are used in alternate course. Header bond. It is the arrangement of bonding in which all the bricks are laid along the header in each course. In order to break the alignment of vertical joints to be in straight line, their required bed is used in each alternate course. Terracotta. Terra means clay and cotta means burnt. Terracotta is a clay product. It is not necessary. Okay, you can see. Thank you for attention. Thank you.